Good morning to one and all. Today in this lecture, I am going to explain how to form negation of quantified statement. There are two rules to write the negation of quantified statement. In that one, first one, for universal quantifiers are denoted with the symbol this one. Replace the universal quantifiers by the essential quantifiers. So replace this with their exist symbol and open statement by its negation. Open statement means if we have p of x, we put negation front of the p of x. This is first rule. We move on to second rule. Here, if we have essential existential quantifiers, that is there exist, replace this there exist with universal quantifiers, that is for all, the open statement by its negation. Here also p of x is converted as negation of p of x. Keep these two rules in mind. We will find negation of given quantified statements. So first question, write the following in symbols and negate all squares or rectangles. So p of x is all squares or rectangles. Here we have all. For that I am writing for all x. P of x I am writing as it is. Now I need negation of this. So I am keeping negation symbol here, remaining I am writing as it is. We discussed already how to negate given statement. So replace for all with there exist and open statement p of x with negation of p of x. So the negation of this is this one. Now I am writing this as a sentence form. Observe, we have all squares are rectangles. Now I negate this by using symbols. Here I get there exist x. There exist becomes sum. Some squares negation is there. That's why not rectangles. So the negation of all squares are rectangles is some squares are not rectangles. Once again, here all is there. That's why I put for all x. Squares are rectangles. For this one, I am taking p of x. Now I need negation of this. That's why I am simply put negation symbol before this one. For all becomes there exist. Open statement p of x becomes negation of p of x. Now I am writing this, I am converting this symbolic form into English language by some squares are not rectangles. This is first example. We move on to example 2. Here you can observe some term is there. Numbers are odd and every number is not even. The given statement is some numbers are odd and every number is not even. So here I am splitting this sentence into two parts. First part is numbers are odd. Second part is numbers are even. I am removing this not also. So the first part p of x is numbers are odd. Second part Q of x is numbers are even. Now I am going to write this sentence in symbolic form. Observe, here sum is there. For that I am writing there exists x. We know that P of x is numbers are odd. That's why numbers are odd is replaced with P of x. Here and is there. The symbol for and is inverted V. Every is there. For every I am writing for all x. Numbers are even. For this I am writing q of x, but here not is there. That's why I am writing negation of q of x. So the total sentence is converted into symbolic form. Now I am going to find the negation of this one. So there exist becomes for all x is as it is. P of x open statement becomes negation of P of x, and becomes or for all becomes there exist x is as it is. Negation of q of x, it is q of x itself. That's why I am writing q of x here. This is the symbolic form of negation of given statement. Now I am writing this symbolic form as for all is there. That's why all P of x is, for P of x we have negation. So negation of P of x is numbers are not odd. That's why numbers are not odd. This is the symbol which when we use, that is replaced with or, and means this one, or means V. So V, here there exist is there. There exist to be replaced with some q of x. Numbers are even. There exist, for there exist I am writing some numbers are even. Once again, here we have some, for that one there exist x. Numbers are odd is replaced with P of x, and is replaced with inverted V. Every is replaced with for all x. Numbers are even is replaced with q of x. Here not is there, that's why I put negation here. So I need negation of this symbolic form. There exist becomes for all x. P of x becomes negation of P of x, and symbol becomes r. For all x becomes there exist x. Negation of q of x is q of x. Now we convert this into as a sentence. Sum becomes all numbers. Y becomes, here for all is there. All numbers are not odd. Why not? Here negation is there. Or there exist is replaced with some numbers. Number is even. So we move on to third one. That is, if all people are good, then some will be happy. This is the given statement. Here also I am splitting this statement into two parts. First one is P of x, second one is Q of x. P of x is people are good. Q of x is people will be happy. Observe, the symbolic form of this sentence is, here all is there. That's why I put for all x. People are good is replaced with P of x. Then is there. Then is replaced with implies. Some is there. Some is replaced with there exist x. Will be happy replaced with q of x. Now I need symbolic form of this statement. So negation of total I am writing as it is in the bracket. So this is the rule I am going to apply. Negation of A implies B is identically equal to A and negation of B. Here A means P of X, B means Q of X. Otherwise you can take total. This is A, this is B. So observe negation of this one is I am at as it is I am writing as LHS is identically equal to I am keeping A as it is. Here A means negation of X and P of X. That's why this term is as it is. After that I have and, that's why I am putting and. Negation of B is there. This is B. I am writing negation of B. So there is no change in this term because no negation is there. That's why I am writing as it is and also as it is. There exist becomes negation of X. Q of X becomes negation of Q of X. If you want, you can put one bracket here. So now I am convert this symbolic form into a sentence, that is for all is there. That's why I am writing all. P of X we know people are good. That's why for this symbolic form I am writing all people are good. This is and. Again we have for all. For this one I am writing every. Negation of Q of X is there. This is people will be happy is Q of X. Negation of this one is everyone will be unhappy. Happy becomes unhappy. Next we move on to fourth one. At least one parallelogram is a rhombus and all parallelograms are quadrilateral. Now I need negation of this statement. Here also I am splitting the statement into two parts. First one is parallelogram is a rhombus. Second one is parallelograms are quadrilateral. This is P of X. This is Q of X. The symbolic form is once observe. Here at least is there. At least indicates for at least I am replacing there exists X. If there for all I put for all symbol. But here at least is there. That's why I am putting there exists symbol for all X. This is P of X. I am writing P of X. Here and is there. For that and I am putting symbol inverted V. And all parallelograms are quadrilateral. All parallelograms, that's why I am writing for all X. The remaining statement is Q of X only. Now I need negation of this. There exist becomes for all X. P of X becomes negation of P of X and becomes or for all X becomes there exist X. Q of X becomes negation of Q of X. Now I am going to write this symbolic form as statement form as here for all is there. That's why I am writing all. Here negation of P of X is there. That's why I am adding not. So this terms indicates all parallelograms are not rhombus. This is symbol for or. There exist is there. That's why I am writing some of them. Not negation is there. That's why I am adding not. Some of them are not quadrilateral. After framing this sentence, once you read, if there is any changes, you can do. That means where I want grammatically I am saying So fifth example, if all integers are not even, then some integers are natural numbers. This is the given statement. Now I need negation of this statement. I am splitting the statement in two parts, that is integers or even. In the second part, q of x, integers or natural numbers. So first I want to write symbolic form of given statement. Here all is there, that's why for all x. Not is there, that's why negation of q of x. Here sum is there, then in the next video I will continue this question.